Hello, everyone. My name is Luis Correa. I'm going to be doing a project on the types of vaccines and how they work against different diseases. And the reason I'm doing this project is because considering the state of our world and different vaccines and the reluctance to get vaccines, I wanted to advocate for the different vaccines there are and show how they're safe. So essentially, there's three different approaches to creating a vaccine using either the whole bacterium or the virus. The second one being that they get the parts that trigger the immune system, such as the protein caps on the COVID-19 vaccine, or just using the genetic material in general. And since technology is ever growing and vastly changing, there's constantly new ways that we reinvent these vaccines and create new vaccines. So it's not something that's just decided from one day to the other. It's researched for years. So essentially, there's six types of vaccines. There's an inactivated vaccine, a live attenuated vaccine, an mRNA vaccine, the subunit recombinant polysaccharide and conjugate vaccines, toxoid vaccines, and viral vector vaccines. Essentially, inactivated vaccines are vaccines that inject dead viruses, dead versions of the microbes of a particular disease, and they've been used for hepatitis A, the flu, polio, and rabies. And they usually need boosters because they're not as strong as acquiring the live vaccine, as acquiring the live microbe. Essentially, they'll take the killed virus and they'll inject it into you, and through immunological responses, you'll create antibodies. The second vaccine we're going to be talking about is the live attenuated vaccines, and these vaccines use a weak version of the microbes that cause these diseases for these vaccines to be much stronger, as they can cause a natural line of defense to be activated, and they cause small infection to start immunity. So you get an immunological response, but it won't be as strong because the virus is already weakened. And these viruses are very limited to people with immuno compromises because they are alive and they do induce immunological responses. And they've been used against viruses such as MMR, combined virus vaccines, rotavirus, smallpox, chickenpox, and even yellow fever. Our third vaccine, which is one that has been talked about a lot, is the messenger mRNA vaccines. They've been used recently for COVID-19. They're relatively new, but they're highly effective vaccines. And this vaccine implements mRNA, which is translated into proteins that are used to build the line of defense to fight the virus. The mRNA triggers protein synthesis of protein spikes that are found on the virus surface, and they implement them to make antibodies, essentially tricking your body into thinking that it's acquired the virus despite never coming in contact. It is safe and easy to use and has little risk as it does not contain the actual virus. The next set of vaccines are the subunit, recombinant, polysaccharide, and conjugate vaccines. And these vaccines use capsids, proteins, or sugars from the microbes, so essentially any subunit, and they're implemented into your immune system, and they primarily use the parts that will cause an immune response to create antibodies, but they also cause no harm to the patient. These antigens do not infect the cells due to only being a piece of the vaccine, so they only trigger antibody-mediated response. The recombinant vaccine is created by taking small pieces of the DNA from the virus, and it's implemented into bacterial or yeast cells to produce surface proteins of the virus and implemented into immune cells. Due to being one of the weaker vaccines, they are injected into with adjuvants, which are agents that allow the immune system to be stimulated to make the antibodies, essentially tricking the body into thinking that it's acquiring the virus or bacteria, but it's not. These vaccines can be used against HIV, hepatitis B, HPV, whooping cough, shingles, meningitis, and pneumococcal disease. The next set of virus vaccines are toxoid vaccines. They're vaccines use that toxins made by microbes to create immunity only to the parts of the microbe that causes the disease and not the whole microbe, meaning that the immune response will be triggered and attack the toxin, not the whole germ. So these vaccines do need to have boosters to remain protected, and they can be used for tetanus or diphtheria, essentially just getting the toxin and reworking it to become immune to it. The next set of vaccines are the viral vector vaccines, And these vaccines use a modified version of a different virus to send instructions to create immunological protection. And then these are two potential vaccines that are currently being worked on. They're DNA vaccines that use DNA vaccines are easy and inexpensive to make, and they produce strong long-term immunity. And the next set are recombinant vector vaccines, which are platform-based vaccines, and they act like natural immunity, so they're especially good at teaching the immune system how to fight the germs. These are my references, and thank you guys for watching.